Today we're going to talk about relations and functions. So there's some things before we can actually get into examples, get into what we're doing today, that we've got to clarify. Okay? Now, when we do a table, we typically put X on this side and Y on this side. But there's some other words for X that we use. Okay? They all mean the same thing. One of them we use for X is input. My goodness, input. And if X is our input value, what is our Y value? Output. Very good. What is another word we use for X? Variable. What is a variable? Independent. Perfect. Independent clause. So if we call X independent, what do we call Y? Dependent. Guys, that's enough. Okay, another word we use for X, one of the newer ones, it starts with a D, is domain. Domain is always your X value. For your Y value, we call it the range. And we have one more thing that means Y. And that is this symbol. We say this symbol F of X. And this is function notation. There's nothing that means, yes, sir. I just see alpha and I went to my grandma's house. Okay. My alpha's here like years ago. All right, you guys, that's enough. All right, so F of X is just function notation. It's something that means Y. So anytime you see it, that's all it means, is it's your output, okay? Yes, Eva. Yes, it was. Okay, and I said that just means Y, right? All right. So anytime we are doing these two, there are 4 different things for X. X, input, independent, and domain. There are 5 things that mean Y, right? So any of those 5 are interchangeable. So just keep that in mind. The next thing I want to talk about is a mapping diagram. A mapping diagram lists your domain on this side, or your X values, in numerical order. And it lists your range on this side in numerical order. And then once we have them listed in numerical order, we're going to do what we call connect the dots. I'm going to show you one of these in just a second. We use this to determine if a relation is a function. If only one line is coming from every X, then we say yes. Okay, so now that I know I've given you a lot of information, but here's our first example. We're going to kind of put it all together. It's really not that bad. So here's example number 1. This is exactly what you have to do for 8 and 10. State domain and range, make a mapping diagram and determine if it is a function. So we have 4 things we have to do in problems 8 and 10. 4 things. Now you're going to be given a list of points. Let's say the points are 1, 7, 2, 3. Let's go 5, 2, and -1, 4. All right, so the very first thing we're going to do is we're going to put a D and a colon and a bracket. That represents domain. Now we're going to take all of the x values and write them in numerical order for our domain. So we have a 1, a 2, a 5, and a -1. So we're going to start with -1, then 1, 2, and 5. For the range, we're going to do the exact same thing. Take all of the y values and write them in numerical order. So that's 7, 3, 2, and 4. We're going to write those in numerical order. So we have 2, 3, 4, and 7. So that takes care of the first part, state the domain and range. Now we're going to make a mapping diagram. So we're going to draw a column. Our x values of our domain are going to go on this side. -1, 1, 2, 5. Our range goes on this side in numerical order. 2, 3, 4, and 7. Now we said for a mapping diagram, we got to connect the dots. So up here, I've got to connect 1 to 7. So from 1, I draw a line to 7. Here, I'm going to connect 2 to 3. I'm going to connect 5 to 2. And I'm going to connect -1 to 4. This is a mapping diagram. The last thing we do is we look at our mapping diagram. As long as there is only one line from each of these x values, then we can say yes. So here, there's only one line coming from each one of these. So we say yes, it is a function. Okay, let's do another one. No. Example number 2. Same thing. So let's say I have the points 3, 4, 1, 5, 2, 6, and 3, 3. Okay, first thing I want is my domain. So I have a 3, a 1, a 2, and a 3. I'm going to put them in numerical order. Now, if any of the numbers repeat, you only list it once. Okay, so I have 1, 2, 3. My range, same thing. I have 4, 5, 6, and 3. So in numerical order, that would be 3, 4, 5, and 6. Now we make our mapping diagram. My domain is 1, 2, 3. My range is 3, 4, 5, and 6. Now I'm going to connect my dots. 3 goes to 4. 1 goes to 5. 2 goes to 6. And 3 goes to 3. Is this one a function? No, it is not. We have 2 lines coming from the number 3. So this is no. Questions at all? Okay, beautiful. Next thing I want to talk about is the vertical line test. The vertical line test is used on graphs to determine if if a relation is a function. If, when you draw a line, it crosses only once. Then it is a function. So let me give you an example. If I have a graph that looks like this, our U's we were drawing before break, right? And I were to draw a vertical line down. No matter where I draw it, how many times does it cross the graph? Only one time, so this would be yes. If I had something that looked like this on my graph, and I were to draw a vertical line down, how many times does it cross there? Crosses more than once, doesn't it? So this would be no. Okay? All right, so here's example number 3. Use the vertical line test to determine if the graph is a function. This is what you are doing for problems 12 through 14. So you're going to have a graph. And let's say your graph looks like this. I want to know if this is a function. If I were to draw a vertical line down, it crosses in more than one spot, right? So this would be no. Sometimes they call it the pencil test because you can take your pencil and go across your graph, just like a vertical line. Sometimes it's called a pencil test. But yep, that's why it's vertical. Right, vertical. That's why it's called the vertical line test to the pencil. You just got to go across. Okay? Does anybody need another example of this? Yes? No? Okay. All right, moving on. Example number 4. This is going to cover 16 through 20. All right. Find the range given the domain. So your problem is going to look like this. It's going to say f of x equals 3x minus 2. And then after the problem, it's going to have the domain of 1, 2, 3. First of all, f of x in the front means what? Y. So it's just y equals, right? That's all that is. So we're going to start by plugging in our x values to find our range. So this is y equals 3 times our first domain minus 2. 3 times 1 is 3 minus 2 is 1. Then we're going to do it again. We have 3 times the next one in our domain of 2 minus 2. 3 times 2 is 6 minus 2 is 4. And then we have y equals 3 times 3 minus 2. 3 times 3 is 9, minus 2 is 7. Now the question asks for our range. So we take our r, a colon, and a bracket, and we list our range values in numerical order. So this would be 1, 4, and 7. Let's do another one. I kind of keep it in the same example, though. I'm going to just say I have f of x equals negative 2x plus 5. And my domain is 0, 1, and 5. So where do I plug this 0 in at? Do I put it in for this x or this x? The second one, because again, what does f of x mean? All right, so we have equals negative 2 times 0 plus 5. Negative 2 times 0 is 0 plus 5 is 5. We have negative 2 times 1 plus 5. Negative 2 times 1 is negative 2 plus 5 is 3. And we have negative 2 times 5 plus 5. It's how much? Negative 5. Thank you. All right. So we're going to put our R, our colon, and we're going to write our range. What number goes first? Good. Negative 5. Excellent. Then what? 3, and then 5. Is there any question regarding that? Okay. All right. Moving on to example number, what am I on? 5? What do you mean? Let me go back. You're good? Okay. All right. Now, the next example I want to do is going to cover 24, 30 through 34. Is the relation a function? So sometimes we have tables that go sideways. So this is my x and my y. And let's say I have 0, 2, 3, 5, 6, 7, and 10, 5. If you are looking at this table, just look at your x values. If none of your x values repeat, you get to say yes. Do any of your x values repeat? So we get to say yes. Same thing goes if I have points. Let's say I have AB, BC, AC. Is this a function? No. How do you know, Clara? Very good. So this is no. Nice job. Okay. Any questions there? All right. Last thing I need to talk about. So example number 6. Example number 6 is going to cover 22 and 28. Let's go with a car can travel 25 miles per gallon. The car holds 20 gallons. State a reasonable domain and range. So, we're going to talk about this. But first of all, when I say something's reasonable, what does reasonable mean? What'd you say, Eva? Correct. So it has to make sense, right? So we know this car can't travel 1,000 miles, correct? Okay. So first of all, which one of these are independent? Is it the miles or is it the gallons of gas? Yes, the gallons of gas are going to be our independent, right? So that's my X value. And the miles we travel is going to be my Y value. So let's talk about the gallons of gas first. What's the very least amount of gas you can have in your car? You have none, exactly. So we're going to start with 0. Less than or equal to X, less than or equal to, what's the most gallons of gas I can have in my car? 20. So we can either write it like this as an inequality and say it goes anywhere from 0 to 20, or you can write it in interval notation and say it goes from 0 to 20. Of course, it's got to include both of those, right? Now we're going to talk about our Y value. Our Y value is our miles we're traveling. What's the very least miles my car can go? 0, thank you. If I don't have any gas in my car, can it go anywhere? So I have 0 less than or equal to Y, because that's range. And then how do I figure out what's the most gallons of gas, or most miles my car can go? 500. How did you find that? Good, 20 times 25. Or again, this could be written in interval notation from 0 to 500, either way. But this is reasonable, right? I can have anywhere from 0 to 20, or I could have anywhere from 0 to 500. It is on a gallon of gas, or on a tank of gas? Yes, I agree. So you have 2 questions that ask you for reasonable. So you got to think about it, okay? That's all I'm asking you to do. Does anybody have any questions on domain, range, mapping, anything at all? All right, we still have 10 minutes where we can get started, so we are here to help you. All right, so our homework is on page 271 to 272, 8 to 34 even.